Hello everyone. In this video we're going to talk about effect size with the one sample t-test. We talked about effect size last week, so you had an introduction to it. This time it's just a little bit different. Let's take a look. So in this section we're going to calculate the effect size two different ways. We're going to use something called Cohens D and we're going to use something called R squared. So Cohens D is, again, a ratio, the mean difference divided by the sample standard deviation. This gives us a standardized effect size. In other words, it lets us know if the difference that we're seeing between our mean and the population mean, does it really mean anything? Sometimes we can find statistical significance, but the difference really isn't that great. So again, at the bottom, we have a listing of the different levels of magnitude. A Cohens D of 0.2 is a small effect, 0.5 is medium, and 0.8 is considered large. So as you can see, the only real difference in this formula is that we have a sample standard deviation, and that's denoted by that lowercase s. So instead of using the population standard deviation, we're using the sample standard deviation, which is what we estimate the population would look like based on our sample. And as a reminder, that standard deviation has n-1 in the denominator. There is another way to figure out the variability in scores, and we do this by saying an amount that is accounted for by the independent variable. So we call this R squared, and R squared is found by taking the t statistic and squaring it, and then dividing the t statistic squared dividing the t squared plus t squared plus the degrees of freedom. So this is a formula that we use. And what that gives us then is a ratio of the variability that's accounted for by the independent variable divided by all the variability. So in other words, how much of the variability in scores is explained by the treatment effect. So this is another way of explaining effect size. So when we are using R squared, we do have some different percentages accounted for. 0.01 is a small effect, 0.09 is a medium effect, and 0.25 is a large effect. So just two different ways of figuring out, okay, so we have a significant finding, but how meaningful is it really? And as a reminder, we typically don't calculate effect size when we don't have a significant result. But when we do have a significant result, we're left asking, well, how practically important is it? Okay, we've got one more video after this, which will involve just a little bit more practice.